Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. And what's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No. We've got a mixture here. Now, Amy's going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems or want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry. We'll be here next Wednesday night as well. So bring those questions with you if you want, and you could ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam Praxis peeps, big shout out to you guys out there too, and especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm going to jump back on to close this out. And I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
Hey everybody, welcome to Wednesday night math night. I am so excited that you're here joining me. I am Amy Sink, like Dr. A said, and I am one of the math specialists here with Learning Liaisons. And every Wednesday we're here and we just hang out and do math together. So before we get started, I always like to start with an introduction so I know who is here tonight. So if you could tell me where you're from, what test you're prepping for, and if you have any vacations scheduled for this summer. We do not because we have a newborn at home, but so we'll just be hanging out at home. But my favorite place to go is the mountains. If we were to go somewhere, it would be definitely going to the mountains. So where are you from? What test are you prepping for? And do you have any fun summer plans this summer? Even if it's not vacation, if it's a staycation or something. I am going to post the link for tonight's slides down below. I actually remembered this time. So you can access those. And it's not going to have all my notes on it, but it will allow you to practice later on, or you can pause the video and rewatch it or whatever. I'm trying to think if there's anything else. Oh, if there's any concepts that you want me to review in the future, don't hesitate to comment in the comment box. It really helps me kind of build these slide decks for you because this math night is for you and what you need. So just let me know if there's anything that you want me to cover. There are a few problems from people who have specifically requested them. And that's what I love doing, is going over problems that you need me to go over. So hi, Gary. Hi, Joseph. Both people that I have been in constant contact with. I love it. No summer plans and heading to Orlando. You're coming to my area. Welcome to Orlando. So let's go ahead and get started. We are going to start with a high school 6 through 12 problem. We are going to start with a high school 6 through 12, 7 through 12 problem. Hey, Chantal, nice to see you. Oh, so we got a couple of high school people. I love it. All right, so the first problem we have, and this is a problem that was requested by someone in this group, The matrix equation below defines a transformation on the XY plane. Which of the following shows a point P and its image P prime under this transformation? And we see the matrices there. Hi, Milagros. It's nice to see you. So we see that we've got the matrix that's showing what transformation we're going to be applying. And then we have XY. That XY is just the P point that we're looking for. And when we apply this transformation, it's going to equal the coordinate of P prime. So the interpretation of this is critical, because if we can't interpret that, then it's going to be really hard to solve this problem. And half the battle for these high school 6 through 12, 7 through 12 exams is just interpretation of what they've provided us. So we have to interpret this. So we are applying this transformation. Now, do I have that transformation memorized? I don't. Should I have it memorized? Probably, but my brain is cramped with a bunch of other stuff, so I'm not going to put in useless information. Really, this problem is a very quick problem if you use your answer choices to help you. So I'm going to look at my answer choices, and that's one of my favorite strategies to use when I don't know how to solve a problem. So I'm going to look, and I'm going to see where P is in all of my answer choices. First quadrant, first quadrant, first quadrant, first quadrant. My initial P is in the first quadrant. Now, if this problem is overwhelming you or intimidating you, please don't leave. I promise the other problems are going to be appropriate for everybody. This is just a very specific 6 through 12, 7 through 12 problem. So I noticed that my P is in the first quadrant in every example. The only thing that's different is where P prime is landing. P prime lands in the first quadrant here, and it lands on that y equals x line. It lands in the fourth quadrant here. It lands on the x-axis here, and it lands in the second quadrant here. That's really helpful that they all landed in a different quadrant. Here's why. Because we can pick a tester point and call it a day. That's one of my favorite things to do, is to pick tester numbers or tester points when we aren't given any numbers. So I'm going to pick a tester point that is not 1, 1 or 2, 2 or something like that. I'm going to pick a tester point that has different numbers that aren't 1 and 2, just because sometimes 1 and 2 behave not differently, but they can result in multiple correct answers. So usually I like to pick something that's beyond 1 or 2. So I'm going to pretend that the point P is 3, 4. If the point P is 3, 4, and I apply this matrix, and I do matrix multiplication on it, that means that I'm going to multiply these numbers by these numbers, add them together, and then I'm going to multiply these numbers by these numbers and add them together. So this is going to equal 1 times 3 plus 0 times 4. And then it's going to be 1 times 3 plus 0 times 4 again. And I notice I get the point 3, 3. In this case, there is only one solution. If I am applying a positive transformation, all of those numbers are positive. So I want you to think about this. If all of those numbers are positive and I'm multiplying it by a positive point, it's impossible for us to land in any quadrant other than the first quadrant. Here's why. Because all of the other quadrants have negatives. So it can't be B and it can't be D. Could it be C? Possibly, if I don't want to, critically think about that. Now that I see that I got 3, 3, it's either going to be on the x-axis or on the y equals x line. 3, 3 is definitely not on the x-axis, which means A is the correct answer, which makes sense because that line y equals x is going to be 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, and so on. Y equals x. So A is our answer. Like I said, I spent a lot of time explaining that, But if you use that strategy, this problem really won't take you that long. All right, this problem came from a 6 through 12 prep material, or the idea came from that. However, everybody needs to understand how to solve this. This is a very classic GK Praxis core problem as well. A certain finite sequence of consecutive integers begins with -13. If the sum of all the terms of the sequence is 45, how many terms are there in the sequence? Again, just like we did with problem 1, let's break this problem down and talk about what we're looking at. So we have a finite sequence of consecutive integers. That's an awful lot of vocabulary in one section of a sentence. Finite means it has endpoints. So it's not an infinite sequence of numbers. It's finite. It has a starting point and an ending point. It's consecutive integers, which means they're back to back. We're not skipping any numbers. And integers are just like -1, -2, -3, 1, 2, 3. And it begins with the number 13. If the sum of all the terms of the sequence is 45, how many terms are there in the sequence? So what are we doing here? We have to figure out the sum of all the terms, and the sum equals 45. So all of the terms added together equals 45, and I'm starting with the number -13. And I know I'm going to have 27, 28, 29, or 30 terms. So if I know I'm going to have 27, 28, 29, or 30 terms, I'm just going to conceptually think about this. If I'm starting with the number -13 plus -12 plus -11 all the way to plus -1 plus 0, what's going to happen next? I'm going to add 1 and 2, and it's going to cancel out because 1 plus -1 is 0. 2 plus -2 is 0. 3 plus -3 is 0. 4 plus -4 is 0. And you see where I'm going. So by the time I get to 13, I have a sum of 0. Because when I add all those negative numbers together and then all those positive numbers together, they're going to cancel out. So by the time I get to 13, how many terms do I have already? Well, I have 13 over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And I have 13 over here. And then I have one term right here, 0. Well, already I have 27 terms, and my sum is 0 so far because all of the positives on one side and all of the negatives canceled out. So I know it's not 27 terms. Now I'm going to continue to add, because remember, what we're doing up here is adding terms together. So we did -13 plus -12 plus -11 plus -10 plus -9, -8, -7, 6, 0, 1, 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10 plus 11 plus 12 plus 13. All of that equals 0. Plus 14 plus 15. You see where I'm going now. So now I'm going to really figure out what's going to equal 45. So I'm going to whip out my handy dandy calculator. That's like a reference to Blue's Clues if you didn't know. 14 plus 15 equals 29. So we're going to add 16 onto that, and that equals 45. So I started with 27 terms, 28, 29, 30. We have 30 terms being added here. Now, another situation that they like to throw in with these kinds of problems is we have a finite sequence of consecutive odd integers. If we see the word consecutive, it still means back to back, but we're looking at consecutive odd integers, then we would be technically skipping an integer, but we would be looking at odd numbers. So I would be looking at 1, 3, 5, 7. Those are consecutive odd integers. The same thing could be said for consecutive even integers as well. But I just wanted you to know that, because if it says consecutive, it does mean back to back, but we also have to look at the criteria that we're using. All right, let's move on to number 3. This is another, actually, you know what? We're going to skip number 3. I'll come back to number 3, I promise, but I want to give a problem for my elementary Praxis core GK people, because we've been doing a lot of upper level math. Which of the following best describes the shape to the left? So I immediately see 3 options for octagon and 1 option for star. I'm going to count the number of sides and see how many sides we have. So we have 1, 2, 3, 4, 5, 6, 7, 8. So this is an octagon. A regular star, that's not really a classified shape. And so we don't want to get tempted with an answer like that. So a regular octagon, a convex octagon, or a concave octagon, what are we looking at? So a regular polygon is going to be same size sides, and it's going to be convex. So a regular hexagon is going to be all the same sides, 3, 4, 5, 6. Up, I did not want it to turn into a circle. 1, 2, 3, 4, 5, 6. That's a regular hexagon, because all of the sides are the same and it's convex, which means it's kind of blown out like a balloon. Concave, a concave shape has caves inside of the shape for a bear to hide in. That's the most elementary way I can explain it, but I'm an elementary school teacher who is certified through 12th grade, so I tend to use elementary terms. So in this shape, if a bear were to walk around, there's no caves for it to hide in. But in this shape, if it were to walk around, there would be a cave, that would be a cave, that would be a cave, and that would be a cave. This is a concave shape because there are caves for the bear to hide in. So this is not a regular octagon. A regular octagon would look something like this. It's your typical stop sign. I don't draw them very evenly, but you know what I'm talking about. A convex octagon, this would be a convex octagon, but a convex octagon could also be a non-regular shape that's convex. So it could be something like 1, 2, that's not what I meant to do. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. That would be an octagon that's concave, that's not regular, because those sides are not the same size. So this is just a concave octagon where this would be convex and this would be regular convex. Hi Laura, hi Tanisha. GK math, awesome. Joseph, yes. That, you know what? I meant to do that when I saw this problem and I totally forgot. I will absolutely add a sum of a geometric and arithmetic sequence problem to next week's set. That's a great question, because people are going to have to know those formulas, and those are just formula-driven problems. If you don't know the formula, you're not going to be able to solve it. So I will absolutely add those to next week. Let me make a note of that while we read this problem. Geometric and arithmetic sequence problems. All right. Again, if you want me to add things to next week, just let me know. Hey, Terry, if the product of 2 consecutive odd numbers is 48, what is the value of the larger number in this series? Now, this one is not so straightforward as this one was. We actually Could use like guess and check, but we're going to specifically use an equation to do this. Could you use guess and check? Yes, and I'm going to show you how to use these answer choices to guess and check because it's an effective strategy, but I'm going to show you the algebraic way to do it. So if we have the product, we know that that is the answer to a multiplication problem. You've got to know your vocabulary for these assessments because if you don't, you will get tripped up just by not knowing those vocabulary words. Answer to multiplication problem. Of 2, so I only have 2 numbers this time, where before we were dealing with 30, consecutive, back-to-back, odd, 1, 3, 5, 7, 9, 11, numbers is 48. So I know that the product, I'm reading this realizing that all of these answers are even, but the product of 2 consecutive odd numbers is 48. So this problem isn't going to have a correct answer. That's fun. So let's say the product of 2 consecutive even numbers because all of the numbers are even. We can fix that. All right. So the product of 2 consecutive even numbers is 48. What is the value of the larger number? So if we define x as the first number or the smaller number, then what would the second number in this series be? I could say it's y, but then I can't solve because if I do x times y, because it's a product, equals 48, how do I solve that? I can't. But what I can do is say if this is x, this is going to be x plus 2. Why did I do x plus 2? Because if my first number is 6, my second number has to be 8 because they are back-to-back even integers. If my first number is 12, my second number has to be 14. So if this is x plus 2. Following? So I have x times x plus 2 because it's the product of 2 consecutive even integers equals 48. Now I'm going to FOIL those out or distribute that. X squared plus 2x equals 48. Now I'm going to subtract 48 from both sides. X squared plus 2x minus 48 equals 0. What am I going to do now? Now I have to factor it. Now I have to solve this quadratic. So we just took number sense problems. This is a number sense problem. And we threw in quadratics into it. Now I have to factor this or use the quadratic formula. Because I know that these are consecutive, even numbers, I know that it's factorable. I know that I can factor it. If you don't know how to factor, go watch a Khan Academy on factoring because it could literally take an entire hour for me to explain factoring. So x times x equals x squared. What times what is going to be negative 48, but positive 2? Well, I know 8 times 6 is 48. And if it's a positive 8 and a negative 6, then it's going to give me a negative 48. So that said, x minus 6 equals 0. X plus 8 equals 0. So x equals 6 and x equals negative 8. Now, those are not consecutive. One of those answers is extraneous, which means it doesn't work in this problem. It's not going to be a negative 8 because they are consecutive even numbers and the product equals 48. So if x is 6, then x plus 2 is 8. So my numbers are 6 and 8. But they asked for the larger number in this series, which means it's 8. Now, here's how you would use your answer choices to solve that. Because this process, for me, would take less time. But for many of you, it would take more time because you'd have to dust off those cobwebs from quadratics. So let's look at how to use the answer choices, because using the answer choices for a problem like this is an excellent strategy. Yes, very confusing. So if these are the larger numbers in the series, because that's what they asked us to find, because they asked us to find the larger number, the answer choices are going to be the larger number. So if 4 is the larger number, what is the smaller number that is a consecutive even number? 2. What is the consecutive even number that's smaller than 6? 4. What's the consecutive even number that's smaller than 8? 6 and 8. When I multiply those, 4 times 2 is 8, 6 times 4 is 24, 8 times 6 is 48, 10 times 8 is 80. That didn't take any time at all, did it? So in this case, you don't have to know how to do quadratics. You can just use your answer choices, and it makes it that much easier. All right, problem number 6. This is specifically for my pre-K through 3 people. I have not seen any pre-K through 3 people in here right now, but that doesn't mean they haven't said hello yet. So I'm going to go ahead and go over this problem, but symmetry is absolutely found on our pre-K through 3 assessments. Which letter has both horizontal and vertical symmetry? So when we look at this, horizontal symmetry says that I can cut the image. Horizontal says I can cut the image in this direction, and it's going to be the same on the top and the bottom. Vertical symmetry says that I can cut the image this way, and it's going to have the same on both sides. So if we think about a butterfly, we often think of a butterfly as having vertical symmetry. And a lot of times in an elementary school, when they're working on symmetry, you'll see them draw a half of a butterfly with paint, and then they'll fold the piece of paper on top of that paint, and it creates a vertical symmetry image for the kids to understand symmetry. But if I cut the image this way, it's not going to have symmetry because these pieces are smaller than these pieces. So that is not symmetrical. So let's take a look at letter V. If I cut it this way, does it have symmetry? Yes. So I'm going to look at vertical symmetry with blue, and I'm going to look at horizontal symmetry with pink. So right now, I'm just going to check off that that has vertical symmetry. Letter H. Does the letter H have vertical symmetry? Let's cut the letter H down the middle right here. Does this side look the same as this side? Yes. So that has horizontal symmetry, or vertical symmetry. I'm sorry, we're doing vertical right now. Letter D. If I cut the image right here, does it look the same on both sides? It doesn't. So we see a straight line on this side, and we have a curved line on this side. So it does not have vertical symmetry. So C is out, because the question asked us for horizontal and vertical symmetry. Letter E, let's cut it up and down. Do both sides look the same? No. This side is closed while this side is open. So D is not correct either. Now let's go through and look at horizontal symmetry. Now, even though I crossed off C and D already, I am going to check the horizontal symmetry just so that you can see it. So the letter V, if I cut the letter V this way, does the top look the same as the bottom? No, the top is open while the bottom is closed. So it does not have horizontal symmetry. Let's take a look at letter H. When I cut the letter H, does the top look the same as the bottom? Yes, it does. So we've found our answer because B is the only one with a double check mark. But let's keep going just so that you can see it. Letter D. Does letter D have horizontal symmetry? Yes, it does. The top looks exactly the same as the bottom. And letter E. Does letter E have horizontal symmetry? Yes, it does. So all of them except for the letter V had horizontal symmetry, but only the letter H had both vertical and horizontal. Do I have any example problems relating to this theorem? I'm assuming it's fair game. I don't know if it's fair game. I will look at the TExES 7 through 12 exam blueprint to see. And if it is fair game, I'll add it to next week. I do not have any problems developed around that theorem, but I'm more than happy to make one. That's not hard. Okay. All right, symmetry. We good with symmetry? All right, let's keep going. Simplify. Order of operations. Okay, so order of operations gets people every single time. I tutor people, I tutor adults, I tutor middle schoolers, I tutor high schoolers, I answer questions on Facebook. Order of operations is a huge, huge question because not only will they have problems that are just simplify, but if you don't understand how to use the order of operations appropriately, you're really going to struggle with a lot of other problems because you're not going to be able to solve equations and problems correctly. So let's take a look at this problem. I'm going to rewrite it. I always rewrite problems that require me to use the order of operations just so that I can do my own work in my own space. So 5 plus 4 parentheses 2 minus 3 squared parentheses divided by 7 minus 3 parentheses 2 minus 4 squared. All right. What does order of operations say? Order of operations says PEMDAS. Please excuse my dear Aunt Sally, parentheses, exponents, multiplication, division, addition, subtraction. So when we look at this, we want to think of these as partners. When they are partners, you can do either one first, whichever one comes first in the equation. So multiplication, division, addition, subtraction, parentheses, exponents. So I'm definitely going to do the parentheses and exponents first. Let's just start there. So I'm going to solve the parentheses first, and then I'm going to keep everything else the same. So we have 5 plus 4, 2 minus 3 squared. So 2 minus 3 squared. Because the 3 squared is inside those parentheses, this exponent is inside the parentheses. I have to do that exponent first. So I'm going to replace that with a 9 because 3 squared is 9. Then I'm going to solve this parentheses. 2 minus 4 is negative 2. If you have questions about how I'm solving this, please don't hesitate to drop it in the comments because you're probably not the only one with this question. All right, let's keep going. Now, I'm going to copy and paste this section, and I'm going to solve the next part. So what am I going to do next? I'm going to solve my parentheses next. What is 2 minus 9? 2 minus 9 is negative 7. So that becomes negative 7. And what is negative 2 squared? I am not going to do 7 minus 3 first. I am not going to do negative 3 times negative 2 first. I am going to do negative 2 times negative 2 because negative 2 times negative 2 is negative 2 squared. Negative 2 squared is positive 4, because negative 2 times negative 2 is a positive 4. I'm going to keep going now. I'm going to look for multiplication and division now, because I have finished my parentheses and exponents. Yes, there's still parentheses, but there's nothing for me to do with it. So now I'm going to look at multiplication and division. What am I going to do first? I'm going to do 4 times negative 7 first. Why? Because it comes first in the problem. Then I'm going to do the division next. Then I'm going to do this multiplication, because I don't have to do multiplication first. I'm going to go in the order that they show up in the problem. So 5 plus negative 28, because 4 times negative 7 is negative 28. I'm going to change this to a division symbol like that, and I'm going to keep everything else the same. Now what am I going to do? Now I'm going to do negative 28 divided by 7. So 5 plus negative 4, because negative 28 divided by 7 is negative 4. Keep everything else the same. Now what am I going to do? Now I'm going to do this multiplication. So we have 5 plus negative 4 minus 12, because negative 3 times 4 is negative 12. Now what am I going to do? I have finally finished my multiplication and division section. So now I'm going to move on to my addition and subtraction. And I'm just going to move from left to right. So I'm going to do 5 minus 4 is 1. 1 minus 12 is negative 11. So our answer is A. Anybody have any questions about that? All right, let's keep going. Let's go back to that problem we skipped earlier, because I don't want to skip it. A ball is dropped off at a height of 800 feet. The height of the ball over time is modeled by the function h of t equals 800 minus 16t squared. Find h prime of 2 and explain what it means in the context of the problem. So in this specific problem, a ball being dropped off of a building is a very common quadratic, and it's a very common problem that you'll see when they're looking for derivatives and integrals, when we're looking for velocity and acceleration. This is going to be a 6 through 12 problem. So when we are dropping the ball, this is our position function. So h of t is the height of the ball after 2 seconds, or after 3 seconds, or after 4 seconds. When we find h prime of t, we are finding the velocity. And when we find h double prime of t, we are finding the acceleration. So we want to find the derivative of this function, and then we can plug in the number 2 into that derivative. We are not going to plug the number 2 into the original position function, because they asked us for h prime, which is your first derivative, which is your velocity function. So h prime of t equals, I'm actually going to rewrite this, because we're going to have to use the power rule, and it's kind of written backwards in my head. So I'm going to rewrite it in standard form. It just helps my brain. So h prime of t equals, I'm going to take this exponent, drop it down in front, and subtract 1. That's how the power rule works with derivatives. So negative 2 times 16 t to the first power, because 2 minus 1 is 1, plus 80. No, not plus 80. I don't know why I did that. There's no exponent, or an exponent of 1, and when I drop that down and then add a 0, that just disappears. So Now I have h prime of t equals negative 32t. That's it. Now, when I plug in the value of 2 into this equation, h prime of 2, all I'm doing is taking that 2 and plugging it in. For my people who are not 6 through 12 test takers, you might be middle school or GK. If they ask you to do f of 3 or h of 4, you're taking that value and plugging it into all of the variables that was in there. So f of x, we would take this 3 and plug it in for all those x values. So h prime of 2 means I'm going to plug 2 in for t. So that equals negative 32 times 2. Negative 32 times 2 is negative 64. That eliminates C and D. So, is the ball falling at a rate of 64 feet per second? Or is the ball fallen to 64 feet, a height of 64 feet? Well, the ball has not fallen to 64 feet because that would be a position. And that would be our initial function. So it's not going to be B, it's going to be A. All right, we are chugging right along tonight. As, again, I'm just going to keep reminding you because as new people come in, I want them to know as well. If you have questions while I'm solving these problems, ask. And if there are other things that you want to see me solve, some of these problems are from people requesting, or they want an example of a line problem, or they want an example of a matrix problem, or they want an example of a geometry problem. Ask. That helps me build our slides for the upcoming weeks because it's what you need. You're the one preparing for the test. I want to give you exactly what you need. So let's move on to problem 8. Hey, it's another position velocity acceleration problem. How ironic. A particle is moving along the x-axis so that its position, original function, at time t is given by this formula. This is our position function. What is the acceleration at 2 seconds? So they are asking us to find s double prime at the value of 2. So the first thing I have to do is find s prime. Then I have to find s double prime. Then I can plug 2 into that. I am not going to plug 2 into this position function. Otherwise, it would give us its location after 2 seconds. So let's go ahead and get started. S prime of, well, no, I did this last time too. S of t. Let's just rewrite the function. 1/3 t cubed plus 5t squared plus 6t minus 4. All right, now for me to find s prime of t, I'm going to use the power rule, drop it and subtract. So 3 times 1/3 t squared, because the exponent drops down by 1, plus 2 times 5 t plus this 1 drops and multiplies by the 6. 1 minus 0 is, or 1 minus 1 is 0, and t to the 0 power is just 1. And then there is no derivative of a constant. So now 3 times 1/3 is just 1. 2 times 5 is 10. 1 times 6 is 6. That is s prime. But now I need to find s double prime, so I'm going to do the same thing. Drop it, 2t plus 10. And now I'm just going to plug in 2. S double prime at 2 equals 2 times 2 plus 10, which equals 14. Any questions? Now, if you are taking elementary, middle school, GK, math, Praxis Core, any of those, you will not have to know how to do this. So do not stress. In fact, let's go to a K6 pre-K kind of problem. Pre-K 3. This is not a pre-K problem. It would be pre-K through 3. Which of the following is the 254th shape based on the pattern above? These are always tricky. So, do I have time to sit here and go 1, 2, 3, 4, 5, 6, 7, 8? And then I notice that this is the same as this. So, it's going to repeat. This pattern is repeating after that 8th term. And that's why they put this here to show you that that is going to be the next term. So it's an 8-term pattern. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Do I have time to go all the way up to 254? I really don't. Could I? Yeah, I could sit here and do that. But the probability for error is high because your hand is just going across that pattern 254 times. However, if you don't know how to solve this problem and you've got all the time in the world, let's say you finished early and you want to go back and check your work, you could absolutely sit here and do that method. I'm going to show you a more efficient way. But like I said, if you've got extra time and that's the method you want to use, by all means, go for it. Because we know this is an 8-shape pattern, I know that I can divide this by 8 and find out where we're at. So let's take a look. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I'm going to stop there. I would not do this on the test. I'm showing you this to prove why I'm going to do this. So if I asked you for the 16th term, you could divide 16 by 8 because there are 8 terms in this pattern. 16 divided by 8 is 2. What does this 2 mean? It means that we went through this pattern a total of exactly 2 times and we landed on that last shape. However, if I asked you for the 17th term, we already know that this would be number 17. Let's see what would happen if I divided 17 divided by 8. I know 8 can go into 17 2 times with a remainder of 1. That remainder tells me which of these shapes is going to be my answer. So if it's a remainder of 1, it's going to be this shape. If it's a remainder of 2, this shape. If it's a remainder of 3, 4, 5, and so on. So all I have to do is take this number, divide it by 8, see what our remainder is. 254 divided by 8. Now, I am not going to use a calculator because this is a problem that I modified from some K6 prep materials. So I don't want to use a calculator because most K6 exams do not allow for a calculator. 8 goes into 25 3 times. 3 times 8 is 24. 8 goes into 14 1 time. 1 times 8 is 8. And I'm left with 6 left over. So what does this mean? This means I'm going to go through the pattern a total of 31 complete times. So 1, 2, 3, 4. It's going to go through that 31 times. But then I have a remainder of 6, which means 1, 2, 3, 4, 5, 6. This is going to be my answer. It seems so straightforward, doesn't it? All right, we have time for one more, and then I'm going to turn it back over to Dr. A because he has a special code for those of you who are still with us. A triangle is shown below. Is the triangle a right triangle? Yes, because angle B looks like a right angle. Yes, because 8 plus 7 is 15. No, because 113 does not equal 225. You cannot tell with the given information. So, what immediately pops into your head when you see a potential, and I'm going to do it with dotted lines because we don't know, a potential right triangle? You should immediately think of Pythagorean theorem. Pythagorean theorem says a squared plus b squared equals c squared, where a and b are your legs and c is your hypotenuse. So if I do this squared plus this squared, it should equal this squared. Let's test it out. 7 squared plus 8 squared equals 15 squared. Why didn't I do 15 squared plus 7 squared? Because in an actual right triangle, your legs are adjacent to your right angle and your hypotenuse is always across. Your hypotenuse is always the largest side as well. So 7 squared is 49, 8 squared is 64, and 15 squared is 225. 49 plus 64 is 113, and does 113 equal 225? No, it doesn't. So this is not a right triangle because 113 does not equal 225. All right, I am going to turn it back over to Dr. A. Before I leave you, let me know if there's anything else that I can add to next week's slide decks. Is there anything that you want to see again? Or is there anything that you're really struggling with that you're like, man, I really wish she would solve that problem? Or maybe you're working through some studying this week and you come across a problem you're struggling with. Send it to me on Facebook or tag me in a post on our Facebook page on the Learning Liaisons Customer Hub, and I'll be more than happy to add it to our set for next week. I did get, Joseph, I got your geometric and arithmetic sequence, and Gary, I got your, I don't even know how you say that, Chebyshev's theorem. The problems with switching X and Y, inverse problems. That's a great one, inverse problems. I will absolutely add that. All right, I will see you all next week. Let me know in the comments if there's anything you want me to go over. And at this point, I'm going to turn it back over to Dr. A. It's all you.
All right, so wasn't that an amazing session? Now, I know, depending on what exam you have to take, you're like, man, that was great, but she didn't address everything I needed. She focused on all different questions, and I just need elementary, or I just need middle school, I just need high school. Don't worry. Since you're still with us, I've got a special surprise for you. If you use the coupon code, all capital letters, SINK35, that's SINK 35, that will take off 35% off any of our prep courses on our website at the Learning Liaisons. It doesn't have to just be math. It could be anything that you need that we offer. And this is going to be an ongoing deal for you guys who attend these live sessions, because these are great. I'm sure Amy opened your eyes to some new concepts, some new ways to tackle problems, building that confidence. But this is just a smidget of your exam, the concepts on your test. So if you want the comprehensive view with the practice with Amy, with the practice test, with the lessons and the content review, we've got your back on our video boot camps, which all of them feature Amy Sink, your math specialist. So if you want to take advantage of that, the code is SINK35. You can use that at checkout on the learningliaisons.com website. And all that information is on our website as well, and on the bottom of the screen in this video. So we are here to help you. Once again, always remember, it's when you pass, not if you pass. Thank you for joining us again today, and hopefully we'll see you next week too. Talk to you soon.